Training in Weld Quality Assurance and Quality Control. Section 5, Destructive Testing Methods. Topic 4, Guided Bend Testing. The objective of this topic is to know the procedure used to perform the guided bend test and the results derived from the test. The basic purpose of the guided bend test is to determine the soundness and ductility of weld metal by bending the specimen into a U shape, then evaluating the surface of the bend. This test is perhaps one of the most popular because of its simplicity and its comparatively low cost. Because it provides a tension and compression load on a weld specimen, it is helpful for determining if weld and base metal are thoroughly fused. The test is used to provide evidence that a welding procedure will produce quality welds with a minimum of discontinuities. It is also used to determine the welder's ability to deposit sound welds on plate or pipe. There are 5 types of bend specimens: transverse face and root bends, transverse side bends, and longitudinal root and face bends. Each of these specimens are evaluated in much the same way. The dimensions of the specimen are important, although not as precise as those used for tension and impact testing. Transverse face and root bend specimens are removed perpendicular to the axis of the weld. In some cases, the specimens are removed 1 inch from both sides of the weld's transverse center line. The actual location and number of specimens depends on the specification or code in use. Generally, the length is a minimum of 6 inches. The width of the specimen is normally no more than 4 times the material thickness. The thickness is equal to the base metal thickness and generally does not exceed 3/8 inch, although this may vary slightly from code to code. On thicker materials, it may be necessary to machine the specimens to 3/8 inch prior to bending. Before bending, the weld reinforcement is usually removed. A care must be taken to avoid going below the surface of the specimen. The grinding or machining should be parallel to the longitudinal axis of the specimen. This is true of all bend specimens. The transverse face bend is positioned in the bend fixture so that the face surface becomes convex after bending. For the root bend, the root surface becomes convex. The transverse side bend is generally used on material 3/8 of an inch thick or more. However, the thickness of the specimen itself should not exceed 3/8 inch. This specimen is bent so that one of the side surfaces becomes the convex surface. Longitudinal root and face bends are prepared by removing the specimen down the weld axis. The specimen length is approximately 6 inches. The width is approximately the width of the weld plus 5/8 inch. The thickness is equal to the plate thickness to a maximum of 3/8 inch. The longitudinal face bend is bent so that the face surface becomes the convex surface. The root is bent in a similar manner. The requirements for the type and number of specimens, the location from which they are taken, and their dimensions are detailed in the testing procedure or the applicable code. Equally important with the care taken in preparing the test specimens is the setup of the guided bend machine. There are basically 3 types: the conventional plunger and shoulder type, the roller, and the wraparound. The conventional plunger and shoulder machine consists of a plunger that applies the bending load and a set of shoulders which acts as a die to form the prescribed specimen. The roller machine works in much the same way, except that rollers are attached to the shoulders to minimize resistance during bending. The wraparound machine is much different. It holds one end of the specimen and forces the other end around a prescribed size die in order to shape the specimen into a U. Regardless of the type used, the machine must be set up to provide the required radius on the specimen. The requirement will differ with each code, so care must be taken to ensure the proper setup. As an example, a 3/8-inch specimen to be bent on the conventional plunger and shoulder machine would require these dimensions for proper setup. The plunger should be 1½ inches wide. The radius of the plunger is 3/4 inch. The width between the shoulders is 2 3/8 inches. And the shoulders are to have a 3/4 inch radius. When the specimens are prepared, they are placed on the fixture with the weld centered over the open space between the dies. The plunger is then activated to bend the specimen. Once all the required specimens are bent, the evaluation process begins. The standards of acceptability differ with each code, so care must be taken to use the proper code. Discontinuities may appear during bending due to a lack of fusion, porosity, slag inclusions, or other weld problems. Those exposed on the convex surface are evaluated according to acceptability standards. Some codes require that discontinuities on the sides be evaluated as well. Any discontinuities greater than the allowable code limits are considered unacceptable. As an example, the maximum size for porosity could be 1/8 inch, measured in any direction.